we're going to look at something called factorising algebraic expressions. And in order to do so, we need to find a common factor. And what a common factor is, it's a number or term that divides into every term of an expression. When an algebraic expression has a common factor, we can factorise. So a common factor means we can factorise. Before factorising anything, and the first step you must do, is always checking for a highest common factor. We not only need to look at the sign, but we need to look at the number and the letters. Now, just to keep in mind, factorising is the opposite of expanding. So previously, if you were given a question that was 3 and then in brackets x plus 2, you would multiply 3 times x to get 3x and 3 times 2 to get 6. So, going from left to right in this example is called expanding. And to go in the other direction from the expanded form and to put brackets back in, that's factorising. Now, if you look at 3x plus 6, what do you notice the highest common factor is there? Well, I noticed that looking at the coefficient of this and this number, 3 is the biggest number that goes into both. And that number went out the front of this bracket. And then we're basically thinking 3 times what will give us 3x? Well, it's x, and that's why x is the first number inside of our bracket. And then we think 3 times something needs to give us this 6 at the end, and that would be 2. So that's how we're going to go in the opposite direction. We're going to find our highest common factor first, and then we're going to figure out what needs to go inside of the brackets. So, looking at this first example, we've got 4x plus 12. Everything's positive, but looking at those numbers, I noticed that 4 goes into 4x and it also goes into 12. So 4 is going to be my highest common factor. Just checking, do we have any letters in common? No, there's only a variable on the first term, but not on the second. So now we put in our brackets. 4 times what is going to give us 4x? Hopefully you recognise that's x. And then we need something times 4 to give us plus 12. Hopefully you recognise that's going to be 3. Now, on the side of your page, you could check that. You could do 4, and then in brackets, x plus 3. 4 times x is 4x. 4 times 3 is plus 12. Is that what the question was? Great. So this is helpful as a check, but it's really important you don't accidentally, expand out your brackets again, because your final answer, you want to have brackets. Factorising means you want brackets. Okay, let's look at the next one. We've got 3x plus 9, and we want to find the highest common factor first. So, looking at our values here, I notice that 3 is the biggest number that goes into both terms. What needs to go inside of the brackets is going to be x plus 3, because 3 times x is going to give us the 3x we needed, and 3 times 3 is going to give us the 9 we needed. Next one. We've got 2x squared and 4x. You probably realise that 2 is the highest common factor with the numbers. But now that we've got pronumerals on both of our terms, we need to consider that as well. We need to think, what's the highest value of a pronumeral that works for both? I notice that there's an x squared here and there's an x. So, what we have in common is an x there. If I put an x squared out the front of my brackets, it wouldn't work when I was building my 4x, because 2x squared times something is not going to give me 4x. So that's why we only need a 2x there. So 2x times something is going to give us 2x squared. That's going to be x. 2x times x is 2x squared. Then we need 2x times something is going to give us plus 4x. Well, it needs to be a positive because we need a positive times a positive to give us a positive answer here. But then what else do we need? Well, we're going to have a 2 because 2x times 2 is going to give us 4x. Okay, a little trick. If both numbers are negative, we're going to have a negative as part of our highest common factor. So let's note that down. So when both terms are negative, we're going to take that negative out in our highest common factor. Okay, so what else do we notice here? We've got 7x squared and we've got 49, just thinking about the numbers and the letters. I notice that 7 goes into both of our values. I can't put an x or an x squared because we don't need that to build this last term here. So putting in our brackets, negative 7 times something is going to give me negative 7x squared. That something needs to be x squared. And then negative 7 times something to give me negative 49. I'm going to have to make that plus 7. Next example. We've got 7a squared plus 63ab. Both of these are positive. 7's the biggest number that goes into both. 7 goes into 7 once, and it goes to 63 9 times. And I notice I've got an a squared here and an ab. The largest common factor with the variables is just going to be an a. I can use that to build the a squared, and I can use that to build the ab. Can't take out an a squared because that won't work for the second term here. Let's put in our brackets. 7a times something is going to give me 7a squared. Well, we need an a there to achieve that. And then 7a times something else is going to give me plus 63ab. Let's think of sign number letter here. We need a plus because that's positive 7a times a positive to give me the positive I need here. And then we said before 63 divided by 7 was 9, so we need a 9. 9 times 7 is 63. We also need a b here, because thinking on the side of our page, 7a times 9b is going to give me 63ab, which is what we want. Okay, in our final example here, we don't just have 2 terms we've got to think about. We've got 3 terms. Let's think about this. In terms of the sign, they're not all negative, so we're not going to take a negative out the front here. Let's think of the numbers now. We've got 16, 10, and 2. And the highest common factor of 16, 10, and 2 is going to be 2. Now we're going to look at the variables, or the letters. We've got an AB, a B squared, and an A squared B. What's the highest letter that we have in common? That's going to be B. We can't have an A because this middle term doesn't have an A. It needs to be a B because every term's got a B within it, and we can use that to build it. If you didn't include this B here, you wouldn't have found the highest common factor. You need to find it for the numbers and the letters. Okay, so now that we've got our 2B, we're going to have 3 things inside of the brackets. Something times 2B is going to give us 16AB. Well, let's think of the number first. 2 times 8 will give us 16. And we need an A in there, because otherwise we couldn't build that A in the 16AB. Now we need to build the 10B squared using 2B. 2B times something is going to give us 10B squared. Well, we're going to need a positive, because it's positive 10B squared and positive 2B. We're going to have a 5 to build that 10, and we're going to need another B to build that B squared. Our final term we're building is negative 2A squared B using 2B times something. We're going to need a negative to build that negative. We've already got the 2 and the B, so we're going to need negative A squared there. If you wanted to check on the side of your page, 2B, 8A plus 5B minus A squared. Expanding that out, we'd have 16AB plus 10B squared minus 2A squared B. And is that what we started with? Yes. So a really nice check on the side of our page. Make sure you don't just do it underneath, because otherwise you will have undone all of the hard work that you did. So a nice check on the edge of your page. Okay, let's get into some trickier examples. We now have some things with brackets in them already. However, these are not perfectly simplified here. and we want to factorize these using a really special technique. It's something called factorising by grouping. So, let's look at what we've got here. The first example, we've got a, and then in brackets a plus 1, plus 3, and then in brackets a plus 1. If I put a box around the a plus 1 here, and the a plus 1 here, can you see that we have this box in common? Now, let me give you a slightly different example. If you had ax plus 3x, and you wanted to factorise that, you would take the x out as our common factor. And then inside of the brackets, that would become a plus 3. So, instead of x, say, we had a box. We had a times a box plus 3 times a box. We would put that box out the front. So let's copy that into what we've done here. Because we have a box in common. We have a times a box plus 3 times a box. Let's reveal. I nearly said unveil. Let's reveal what was actually inside of that box. We had in brackets a plus 1. So rather than having a box here, we could replace that with a plus 1. That's what was inside of the box. And now we've done something really incredible. We have factorised one of our double bracket expansions. So let me go through how we did that one again. We said that the common factor we had here was this a plus 1 in brackets. So we put that a plus 1 in brackets out the front. And then we said, okay, what remained? We're going to scoop these up and put it into this bracket here. So what remained was a plus 3. This is a little trickier, so I think we're going to need a few more examples for this to make perfect sense. So in this example here, what do we have in common? We have this x plus 2 that's common. So let's take this common factor out, x plus 2. Then what remains? That's going to go into the next bracket. So this 3 we're going to scoop up, and this minus x we're going to scoop up. Because remember, this 3 was multiplied with the x plus 2, and the minus x was multiplied with the x plus 2. They had the x plus 2 in common, so that was like our highest common factor. So this is what we mean by grouping. We've taken this group out, and then we grouped what remained together again. Let's practice this a few more times, because this will be new to most of you. I notice we've got that x minus 2 again. Before we keep going with this question though, what number goes in this gap here? Well, hopefully you remember that's going to be a 1, and paired together with that negative, that's a negative 1. So let's take out that common factor of x minus 2 here. And in our brackets, remember, we scooped up what remained. So we've got an x here, and we recognise we had an invisible 1, making a negative 1 here. So here we're going to have x minus 1. That's our final answer. If you can get your head around these kinds of questions, it's really, really nice, because all you need to do is identify that x minus 2 is common, and then scoop up those other values here. Remember, this is factorised, because factorised things are in brackets. And I'm going to be very punny and put brackets inside of brackets here. Okay, final example of this. We've got 7 minus 3x and 7 minus 3x. So we're going to then write our common factor of 7 minus 3x. Now we need to scoop up what was left behind. Oh no, what's in front of this? hopefully you can see that it's like we've got an invisible 1 here. It can't be nothing and it can't be 0 because otherwise that bracket would have disappeared. So it had to be an invisible 1. So we're going to scoop up that invisible 1 and we're going to scoop up this plus x here. And by almost magic, we have completely factorized this by grouping now. We've put this into brackets in the simplest possible form. Now, let's make it a little bit harder. What we've done here is we've gone one step backwards. We don't even have those first set of brackets here. So what we're going to get you to do is you're going to factorize this first pair and this second pair, pretending they're their own example each. So just doing a single bracket expansion. So factorizing the first pair, it's like we're going to pretend the other pair doesn't exist. Okay, now let's do the second half. Let's factorize this pair here. We're going to have our highest common factor will be 2, and we're going to need a plus 2 there because it's positive. Then inside of our brackets, we're going to have x plus 3. Aha! I notice that when we did our factorizing here, we had, just like in the previous questions, a common factor bracket, and that was x plus 3. So let's write that in. And then we just need to scoop up the things that were attached to that highest common factor. So we're going to scoop up that x and scoop up this plus 2, because x times this bracket was the x times x plus 3, and 2 times this bracket was the 2 times x plus 3. So that is our final answer here. We're going to do the same thing with this example. This year, we're pretty nice. We're only going to make you factorize things that we've already paired up for you. But in future years, we could jumble this all around, so we won't do it this year. Okay, factorizing the green part here. The highest common factor is going to be 5x, because we've got 5 and 10. Highest common factor with numbers is 5. We've got x, y, and x, so highest common factor will be x. Then inside of our brackets, we're going to have y minus 2. So knowing that we're doing this by grouping terms, we're really hoping when we factorize this, we're also going to have a y minus 2 bracket. That will help us know we're on the right track. Okay, let's now factorize this second one here. The highest common factor is going to be 4, and then inside of our brackets, we're going to have y minus 2. You can see that we've got a y minus 2 in common. Y minus 2. And then what goes inside of the other bracket? We just scoop up what was attached to it, 5x plus 4. And that's our final form there. We've got everything nicely in brackets. That's what factorizing means. Okay, last one to try here. Our first pair of terms is this one, and here's our second pair of terms. I'd like it if you could have a go at this one and see if you get the same result as me. Did you see this invisible one? It's a tricky one. Okay, so that was factorizing. We factorized some simple single brackets, we factorized using grouping, and then we factorized by having to group the terms ourselves.